Assalamualaikum warahmatullahi wabarakatuh. My name is Danish Zafrin bin Mat Khusaini. My student ID is 20244271 and 196. And right now, I'll be presenting about my CSC508 data structure assignment 2. First, let's start with the building block of our data structures, which is the node class. Each node contains an object data field that stores any type of data, in our case, car objects. And a node next field points to the next node in the list. The node class has three constructors: a default constructor, a constructor that accepts data, and a constructor that accepts data and a reference to the next node. It also has getter and setter methods for data and next, and a toString method that recursively prints all nodes. This allows our linked list to store any type of object and traverse through the list. Now, let's look at the linked list class, which is the foundation for both stack and queue. This class has three private node references. Head points to the first node, tail points to the last node, and current used for traversal. The key methods in linked list class include insert at front, adds a node at the beginning, insert at back that adds a node at the end, remove from front that removes and returns to the first node, and remove from back that remove and return to the last node. It also has methods like isEmpty method to check if the list is empty, and size method to count the elements, and pre method to display the list. This is a classic singly linked list implementation. Now for the stack class. It extends linked list and implements LIFO behavior, which is last in first out. The stack has four main methods, each leveraging linked list methods. Push method is to add to the top using insert at front. Pop method that remove from the top using remove from front. Pick method that views the top using get first. And isEmpty methods that checks if empty using the inherited method. In our car inventory system, the stack holds available cars. When a new car arrives, it is pushed onto the top. When a customer books a car, we pop it from the top. The most recently added car gets booked first. The stack accepts object types, making it reusable for any data type, not just cars. Similarly, the queue class also extends linked list but implements FIFO behavior, which is first in and first out. The queue has these methods: enqueue methods that adds to the back using insert at back, dequeue methods that remove from front using remove from front, get front method views the front using get first, get end method that views the back using remove from front and re-adding it, and isEmpty methods that check if empty. In our system, the queue holds the booked cars. When a car is booked, it is enqueued at the back. When a customer returns a car, we dequeue from the front, ensuring first come, first served behavior. This is the classic queue implementation where the first car booked is the first car that can be processed. Next, the car class. The car class is our data model. It represents a car in our inventory. Each car has four private attributes, which is brand is the manufacturer, model the specific model, the price is the car's price in Malaysian ringgit, and the year, which is the manufacturing year of the car. The class has constructor that initialize all attributes and getter methods for each private field. And lastly, the toString method provides a formatted string displaying all car details. This is what users see when they view the inventory. Now, the car inventory class. This is the main controller of our system. The main method creates a stack called available cars and a queue called booked cars. It preloads 10 cars into the stack. Then, it enters a while loop displaying a menu with 11 options. The loop continues until the user selects exit. Each option calls a specific method, and the entire method uses JOption pane and is wrapped in a try-catch block. Next is the add new car method. The add new car method prompts the user for brand, model, price, and year of the car. It creates a new car object and pushes it onto the stack. Then it shows a success message. And next is the book car method. The book car method demonstrates stack to queue. First, it checks if the stack is empty. It displays all available cars with indices. The user selects an index and it creates a temporary stack called temp, which is temporary. It uses a for loop to pop cars until it reaches the target. It stores the target and pushes skip cars to the temp. After the loop, it restores skip cars by popping from temp and pushing back to available. Then it enqueues the target to the book queue. And finally, it shows a success message. Next is the return book car method. The return book car method removes a car from the book queue by brand. If empty, it will return a message. And it creates a temporary queue called temp. It dequeues all cars. And if the brand matches, it stores the car. Otherwise, it enqueues to the temp. After the loop, it will restore all cars. And it returns either the removed car or a not found message. Next, the display stack method. The display stack method displays available cars. If empty, it returns a message. It creates a temporary stack and pops each car and adds it to output with its index and pushes to the temp. After displaying, it restores the original stack. And now we have the display queue method. The display queue method displays book cars. If empty, it will also return a message. And it creates a temporary queue. It dequeues each car and adds it to output with its index and enqueues to the temp. After displaying, it will also restore the original queue. Now we have the search car method. The search car method searches for a car by brand in the stack. It pops all cars, checks for a match, and pushes it to the temp. After searching, it restores the original stack. And it returns either the found car or a not found message. Next, we have the delete car method. The delete car method deletes a car by brand from the stack. It pops all cars. If the brand matches and not deleted yet, it will store the result. Otherwise, it will push to the temp. After the loop, it restores remaining cars and it returns either the delete car or a not found message. And now we have the calculate sum and average method. The calculate sum average method calculates total and average price. It pops all cars, adds price to sum, and pushes to the temp. After processing, it will restore the original stack. It returns the total and average. And right now, we have find min max method. The find min max method finds the cheapest and most expensive cars. It pops the first car as initial min and max. It compares each car's price. After processing, it restores the original stack. It will also return both the cheapest and most expensive cars. And now we have the filter available under 100k method. The method is stack to stack operation. If empty, it shows a message. It creates a copy of the original stack. It creates a stack called copy and a stack called temp. It copies original to temp by popping all cars and pushing to temp. Then it restores original and creates copy by popping from temp and pushing to both original and copy. Now it processes the copy. It uses a while loop to pop from the copy stack. For each car, if price is less than 100,000, then it adds to output. After processing, it displays the filtered cars. If none was found, it shows a message. Then this is stack to stack because we are copying from one stack to create a new stack. the original data is preserved. And right here, we have the filter book by Toyota method. This method is queue to queue operation. If empty, it shows a message. It creates a copy of the original queue. It creates a queue call copy and a queue call temp. It copies original to temp by dequeuing all cars and enqueuing to temp. Then, it restores original and creates copy by dequeuing from temp and enqueuing to both original and copy. Now, it processes the copy. It uses a while loop to dequeue from the copy queue. For each car, if brand is Toyota, it adds to output. After processing, it displays the filtered cars. If none was found, it shows a message. Lastly, this is the queue to queue because we are copying from one queue to create a new queue. And also, the original data is preserved. And lastly, the expression converter method. This method converts infix to postfix. It prompts the user for an infix expression. It creates an infix to postfix object and calls the convert method. It displays both the original infix and the converted postfix. And if there is an error, it catches and shows an error message. And for the final part, I will show you how my program works.